we're going to look at other tests for zeros of polynomials. What we're going to take a look at is Descartes' rule of signs. So what we know is that the number of positive real zeros of f is either equal to the number of variation in signs of f of x or less than that number by an even integer. The number of negative real zeros is equal to the number of variation signs of f of negative x or less than that by an even integer. So if I just think about the graphs, okay, let's disregard double roots for now. So if I have something like x to the fourth, I can have 4 real zeros, and then I could also have only 2 real zeros. Okay, so that's 4 real zeros, 2 real zeros, and then if you know if it bounces, that's a repeated root, and that's still 2, right? So that's still 1, 2, and that's also 2, so that's still 4. So notice it goes from 4 to 2, and then it could be 0. So it goes by an even integer. Same thing for like an x cubed, for example. So an x cubed, we could say it's like this, and we have 1, 2, 3 zeros. And then we could also have it, the other option that we could have is, well, if it bounces, right? If that bounces, that's still a repeated root, so that's 2, and this is 1, which is still 3. And the other option is that it is just 1, right? Only one solution. So notice it's 3, 1. It's less than that by an even integer. So we're just going to use Descartes' rule of signs to determine the possible number of positive and negative real zeros of this function. So what we do is we look at the number of sign changes. So to look at the positive, we just leave it as it is. This goes from a positive to a negative, and then a negative to a positive, and then a positive to a negative. It doesn't have to be in the correct, you don't have to have all the signs there. I mean, all the terms there. So for example, if there was like the 5x squared is missing, so forth, you don't have to put a 0 there. Okay, we're just looking at the sign changes when it's in standard form. So we notice that there are 3 changes. So what that means is there are possibility of 3 positive real zeros. And then the other option of that is 1 positive real 0. So it can only increase or decrease, sorry, it can only decrease by an even integer, by 2. Let's take a look at the negative. So f of negative x. So the only thing that changes is our odd powers. Okay, so if we plug it in just so you can kind of see it. So we know that the cube will change. That will make a negative 3 cubed. The squared stays the same, because that becomes positive inside, and this becomes a negative 6 and a negative 4. So now we take a look at this, and we notice that there are no changes. So negative, 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 there are no changes. So if there are no changes, then there is 0 possible negatives, real zeros. And what's nice about that is if you know that, then you will never check, for example, like negative 2 or negative 4 or negative 1, because it's not a possibility. So in essence, this kind of helps us doing our rational root theorem by reducing the number of things that we have to check. Okay, so in the homework you'll have to list the possible zeros. So you say possible real zeros, there's 3 possible real zeros, 3 possible positive real zeros, or 1 positive real 0, and then for the negative there is 0 possible negative zeros. So go ahead and try this next example real quick. Just determine the possible number of positive and negative real zeros. Pause the video and try it out. So if you tried this out, you'd have gotten 0 positive real zeros because there are no sign changes up here. And then if you plugged in a negative x, it only changes your odd powers. And so you see that there are 3 sign changes, or a possibility of 3 negative real zeros or 1 negative real 0. So next we're going to use this in order to solve for all real zeros of this next function. So number 1, you have to list the possible zeros, list possible with our rational root theorem. And then number 2, you're going to do Descartes' rule of signs. So Descartes' rule of signs. and then you're going to have to test. Okay, and then you test, and then finish it out. So our possibilities, we have negative 2 over 6. So 2 is on top, 6 is in the denominator. So what that means is I have 1 and 2, so plus or minus 1, plus or minus 2. Then I have plus or minus 1 over 2, plus or minus 1 over 3, plus or minus 1 over 6. And then 2's, I have 2 over 1, that's the same. 2 over 2 is still 1. Then I have plus or minus 2 over 3. And then plus or minus 2 over 6, which is just 1/3, and I already have that there. So those are all my possible roots here. Plus or minus 1 over 6. And so we just need to test something out. I'm going to go ahead and test 1. So 3, 2, 1, 0, nothing's missing. So, let's do Descartes' rule of signs first. So positive real zeros, I notice there's 1 change, 2 changes, 3 changes. So I know that there's a possibility of 3 positive real zeros. If we plug in the negative, f of negative x, we get negative 6x cubed, and that's still negative 4x squared, and a minus 3x minus 2. So what this means is there's 0 negative possible roots. So what that means is I just cut this in half. I don't have to check any of my negatives. I'm only checking positive zeros, positive numbers. So let's test positive 1, right? I don't need to test negative 1 because there isn't one that's possible. So this is 6, negative 4, 3, and negative 2. So 6, 2, 2, 3 plus 2 is 5, 1, 5 is 6, and this is a 4, so that didn't work. Let me just try this 2/3 here, just to try it out. So 6, negative 4, 3, and negative 2. So 3 goes 6, 2, 2 times 2 is 4, this is 0, 0, 3, positive 2, and 0. That worked. Awesome. So x minus 2/3 is 1. Then this is 6x squared plus 3. Then I can factor that. Let's see, I can factor out a 3. And then that is 2x squared plus 1. So this is not a real 0, so I can ignore that. So my only real 0 is x equals 2/3. So Descartes' rule of signs is nice in order to help us to reduce the number of values we can check. And so I hope that helps out. Let's go ahead and try this next example. Find all the real zeros. So it's asking for only the real zeros of 8x cubed minus 4x squared plus 6x minus 3. Pause the video and try it out. So if you tried out this example, you would notice that using Descartes' rule of signs, you would only have 3 possible positive, and then you plugged it in to get the negative, and you know that there's no possible negative value, so you wouldn't try plus or minus 1 and so forth. So I tried 1, what didn't work for me? Then I just tried it a half, and a half worked for me. That was perfect. And so the only 0 that we have is x equals a half.